Hi guys, we'll start in a minute. So today we will be looking at solving simultaneous equations. 3 methods for solving them. We'll look at solving them graphically, solving them using the elimination method, and also, solving them using the substitution method. We'll look at which method's the best to use at various times and why you would choose one over the other. Okay, let's get going. We'll just start with a few very quick warm-up questions. Oh, yep. That's what we're doing. As usual, I'll try and cover as much as possible. Please let me know if I'm going too quick or you want me to go over something again. Eddie Wu videos. So we'll be doing these 3 down the bottom today. Okay, let's warm up. Here's just the graphs of 2 linear equations on a number plane. What is the solution to the system? As in, which values of x and y will make these 2 equations equal? Have I set up the pair deck thing properly? Ah, okay, yes, I thought I'd done that. I started it, but it looks like it's finished. Ah, there it is. Wait, let me, I think I've done it twice. Let me just try this one. I might need to do it again. Oh no. Got 3 students in. So MLRUH, Misty Lemons, Rays, Underwhelmed, Highlighters. Okay, we got 5 in, let's get going. Feel free to join at any stage. Here's the code in the top corner. All right. Let's get back to where we're up to, and here. Okay, now there's quite a lot to get through, so I'm going to race over a couple of things to hopefully get to the meaty part of the topic. Okay, let's, so obviously, if we connect some lines, we can clearly see where it meets up. Have an x value here of x equals -6. Y value here of y equals 4. Now, where's my pair deck answers? Okay. Yeah. Looks like we've got that one sorted. X equals -6, y equals 4. Yep. Yep. This one not quite right. These 2 are good. How do I? Okay, let's get my dashboard open. Okay, got a few responses in. Yeah, so a nice easy one just to warm up. Just graphically, we can see the solution. If we had to figure out what these equations were from the graph, we can do that too. Annotate text. We can see this equation here. If we have y equals mx plus c, we know that c in this case is 6, as it has a y-intercept of 6. And well, it's gone from this point here, which was at minus 6, 4, sorry, minus 6, 4, and it's gone to 0, 6. So that means m is 2 over 6 equals 1 over 3. So we get a final answer of y equals x on 3 plus 6. And this one here, and this one here, let's say, well, very hard to see the y-intercept in this case. Let's not worry about that one. We don't need to do it. Moving on. Clear. Okay. Why is it not clearing my annotations? There we go. All right. Following graph displays a system of 2 equations. How many solutions does this system of equations have? Well, firstly, you'll note that these lines are parallel, and we know that that means they will always be exactly this distance apart, and they will never actually touch. And we also know that a solution to a system of equations is the point where they meet. So if this is the system, the solution here, these lines will never meet, which means that the answer is no solution. This is our answer here, no solutions. If it had infinitely many solutions, that would be a case like this here. So if I had, let's say, here is one line, and let's get another color. Here is my other line. It actually lies over it perfectly, so it is in fact the same line. Then we would have infinitely many solutions. So for 2 lines to have infinite solutions, they must be the same line. To have no solutions, they must be parallel or have the same gradient. In any other case, they'll only ever have one solution. It's impossible to draw 2 straight lines that will have more than one solution. So for any 2 pairs of straight lines, we have 3 choices. No solution, in this case, 1 solution, which is almost every case, and infinitely many solutions if we have 2 identical lines. It's not something you'll ever really get asked. Okay, let's go to the next one. Looks like all of you chose the correct answer for that. That's good. Clear off. Next one. Okay. Now, I haven't discussed the substitution method yet. Some of you probably are already familiar with it. So this is just a very simple one. Without me telling you what the substitution method is, let's see if we can solve this system of equations. Now, the suggestion is to first solve for x. There's a very good reason we'd want to solve for x first. In some cases, solving for y will be the sensible option. But in this case, solving for x is very much the correct solution. If you can show some working as you're solving it, it'll all help here. So, the first thing you'll notice is that in both cases, both equations, we have something in terms of x and a constant term being related to y. So we know that 6x plus 5x equals y. So if y equals 6x plus 56, but we also know that y equals 2x plus 24, then this must equal this. So we can combine the two equations to get this new equation. 6x plus 56 is equal to 2x plus 24. Yeah, it looks like a number of you have something similar to that straight up. Yeah, substitute 2 into 1. Okay, it looks like we know how to do this. So in this case here, both equations were in terms of y, which makes substitution a really easy method to use, because instead of y here, I can just replace y with this. And this is just a matter of collecting like terms. If I subtract 2x from both sides, I'll get 4x plus 56 equals 24. And now I can just subtract 56 from both sides. 4x equals minus 32, excuse my handwriting, dividing by 4. And let me get a better color now. We get our final answer of x is equal to minus 8. Yeah, Oneonone has the right answer here. On the way to it, yeah. Natchiket, x equals minus 8. Great. And looks like we're solving for y. So now once we've got an answer in terms of x, all we need to do is just substitute that back in to either one of the formulas. It doesn't matter which one we substitute into. Let's just choose the first one. So we have y equals 6x plus 56 equals 6. Replace the x with minus 8 plus 56. New color. That gives us minus 48 plus 56, which is y is equal to 8. Is that correct? Let's double check in the other one. If y is 8, does that equal minus 16 plus 24? Yes, it does. So we know the answer must be y equals 8. So our set of solutions, our solution pair is minus 8, 8. Let's have a look. Yeah, x equals minus 8. Well done. That's a good one. That's a good one. Yeah. Yeah, well done. Those of you that are writing the steps you're doing, so substitute x equals minus 8 into 1. That's really good. Very clear setup there. The clearer you make it for your teacher, the clearer it is what you're doing. And if you make the slightest little mistake, they'll know why. Let me just do a very quick demo of this one. So we can just clear all drawings. Okay. I'll just very quickly go through this one. So we can set up the two equations. This is slightly different numbers here. So if we equate the two equations, we can now collect like terms, take away 3x from both sides. Subtract 36 from both sides. That gives us minus 15. And we can clearly see dividing by 3 will give us x equals minus 5. And now we can solve for y. We know that y equals 3 times minus 5. Let's do the second equation this time. Plus 21. Y equals minus 15 plus 21. Y equals 6. And we'll just double check it again. Obviously, if y equals 6, sorry, let's sub into this one. If y does 6 equals 6 times minus 5 plus 36. Yes, it does, because that is just 30 minus 30 plus 36. So like a lot of algebra, it's really useful because you can actually just check your answer as soon as you have one and you know that you're correct. Okay. Let's just move on to a very simple solving simultaneous equations graphically. Notice that the second equation here is not in the form y equals mx plus b. So it will be handy to first convert this into the correct form, and then we'll be able to easily see the x and y intercept. You can see here 4y minus 4x minus 36 all have a factor of 4. So if we divide everything by 4, we will get y equals minus x minus 9. Now we have a nice simple equation. Should be very easy to see the intercepts. Let's just do the first one. We can see this is our constant term here, 9. So that's our y-intercept. X-intercept is when y equals to 0. So subbing in here, we'd get 0 equals x plus 9. So x must be minus 9. We'd expect this because the gradient here is just 1. This will just look like this here. Oops, not like that at all. It will look like this. This is 9. This is minus 9. So we've gone across 9 and we've gone up 9. As the gradient is 1. Anything with a gradient of 1, the x-intercept is always just the negative of the y-intercept. If it's minus 1, the x-intercept is equal to the y-intercept. That would be something like that. We would have 9 here and 9 there. Second one, we can see that in this form here, the y value of the y-intercept must be minus 9. And as a negative gradient, this will also be minus 9. So let's just clear everything. Let's draw it again. So if this is my graph, I have y equals x plus 9, which is this point here, 9 minus 9. And I also have y is equal to minus x minus 9. We know that has to pass through here at minus 9 and has a negative slope, so it's going to look like this here. They both meet at this point here. Yep. Yeah, looks like most of you've got it. That's really good. Let me just clear, clear. Okay, let's go to the next part of this question, which I've basically done already. Hopefully you can draw straight lines with pair deck. Have a go at trying to plot the two lines and then state the value. So I basically did this on the last slide, so it shouldn't be too hard. Not the best tool for drawing graphs, unfortunately, but do your best. You can, looks like you can do the straight lines, which is good. Hopefully you've got the same features I do. Now, if this is in a test on paper, you don't need to plot everything on the number plane, sorry. All you really need to do is plot the key points and label them. So it would be enough to do something like this on paper. Let's go green. Let's undo that one, didn't get the gradient right. Remember from last week, if they're perpendicular, oh, that's not quite right. They will make, sorry, if they form perpendicular, the two lines are perpendicular, they make the right angle here. It means that M1 times M2 must equal to -1, which you can see in this case it does, because we have M1 was equal to 1, M2 equals -1, and 1 times -1 equals -1, which is why we get this right angle here. Back to labeling this. You've got your plane. All you need to really do here is just mark down what these values are here. Obviously on paper it's a bit easier. So this is 9, this is -9, this is -9 here. Doesn't matter what any other points are. We have the point of intersection marked, we have the y and the x-intercept marked. You guys don't have to do it on this graph, obviously. It has the numbers for you. Yeah, always good to label the graphs if you're doing it like that. Now it's very clear which graph is which and which label is which. So to solve equations graphically, you basically just need to identify the intercepts, graph it, and then see where the two lines meet. Now, you might need to draw a table of values for that. And in doing so, you might actually spot the point of intersection first and not actually have to do the graphing. So graphing is useful, I guess, if you have graphing technology or graphs calculator, which you may not be able to use in a test. Yeah, that's a great one there. Let's show. Yeah, good answers there, guys. That's really nice. Okay, that's probably enough. Let's move on to the next one. Okay, clear. Okay, now let's look at solving using the elimination method. We're starting with an easier one here. A lot of the questions in Mathspace are set up with a question at the start where you choose what option you're going to do. There is generally an unlimited number of ways of solving these questions. There's usually one or two really good ways, and there's some really slow ways. So we set them up like this to get you to do it the correct way. So what you want to notice in this question is that we have -3y here, and we have +3y here. So we can combine these two equations so that hopefully these two vanish. So if I add these two things together, +3y and -3y, that equals 0. So what we want to do is equation 1 plus equation 2, which it looks like those of you that have responded have successfully chosen. There are, let's just see, if we did this one, equation 1 plus 2 times 2, then I would have -6y, and I'd be adding that to get -3y. So that's not helping. If I took away equation 2 from equation 1, I'd end up with 6y. That hasn't helped. And if I did 2 times equation 1 minus equation 2, then I'd have 6y minus 3y. It gives me 9y. We're getting further away from where we want to go. So equation 1 plus equation 2 is definitely the best option. Now let's use that method to solve for x first, and then we can solve for y. So remember, we want to add equation 2 to equation 1. I'll slowly work through it as well. So if I add these two things together, 8x plus 3y plus 3x minus 3y, that must equal these two here, the two constant terms. 19 plus 25. I'm running out of room there. Let's just quickly tidy this up. 8x plus 3y plus 3x minus 3y equals 19 plus 25 is 44. We can now collect the like terms. 8x plus 3x is 11x plus 3y minus 3y, they vanish. Now, if you ever end up with an x and a y term once you've done this step, you've probably done the wrong step, because the whole point of this step is to get rid of one of the x's or the y's. In this case, much easier to get rid of the y's first. So we've got 11x is equal to 44. X is then equal to 44 divided by 11. Therefore, x is equal to 4. We can now substitute that back into one of our equations. Let's pick equation 2 because it's just a bit smaller. 3x minus 3y is equal to 25, which means 3 times 4 minus 3y is equal to 25. Let's just do a quick rearrange here. 12 minus 25 is equal to 3y, which means 3y is equal to, what's that, minus 13. That's not a very nice number. Y equals minus 13 on 3. Yeah, correct. Well done. Now, just quickly, this answer here, y equals minus 4.33. If you were to enter that into Mathspace, you would be marked wrong, because this has been rounded. Unless it's been stated, you need to give the exact value. So you could answer it like that to show the recurring decimal. But in algebra, it is best to just leave your answer as fractions in most cases. So minus 13 on 3 is correct, or minus 4 1/3 would also be marked correct. Be careful, always never round unless it asks for it. It's cases like this in algebra that it probably comes up the most, because you want to just give a nice concise answer. Just give you another 30 seconds to quickly finish. We'll move on to another one. Let's check our answer actually while we're doing it. Does 8 times 4 plus 3 times minus 13 on 3 equal 19? Well, 8 times 4 is 32. These 3's will cancel. So I've just got 32 minus 13, which definitely equals 19. So we know we've got the correct answer. It's always really good to double check your answer, because if it's wrong, it becomes immediately obvious and you can just fix it. Okay, next one. Oh, did not mean to just, I thought I deleted that one, sorry. Okay, should have got to this a bit earlier in the lesson. What would you like to focus on? I didn't even put my choices. What happened there? Let's just continue on. All right, back to the substitution method. If that slide was supposed to have a multiple choice asking if you wanted to concentrate on substitution or elimination or graphing, but we'll just move on because I did not put anything. Okay. So we want to solve this following system of equations using the substitution method. Now, we have one equation in terms of y, which is handy. And then we have the second equation, which does have a plus y term. So we want to do something to get rid of the y's. Easiest thing is to use this one here, which has a value of y, and substitute it into equation 2. So I would say the best first step is to substitute equation 1 into equation 2. So equation 2 is minus 2x plus y equals minus 13. We know what y equals. It equals minus 6x plus 59. So we have minus 2x plus minus 6x plus 59 is equal to 13. Let's just remove the brackets. Now we're minusing this 6x term. We're adding the 59. Now I can collect my terms, and let's take the 59 over to the other side. Minus 46. Why are these numbers so bad? Most of the ones you'll come across in your textbook will give nice whole number answers. Dividing by 8, minus 8, we get x is equal to minus 46 on 8, which is not the nicest number in the world. What's that? That's 5 times 8 is 40, so we've got 5.75, or 5 3/4, or 23 on 4. Oops, let's get rid of that straight minus sign. So we've solved for x, and now we can solve for y. Oh, made a horrible mistake. Let's do all that again. It is a nice number. Text. I had 13 on my right hand side instead of minus 13. 2x plus minus 6x plus 59 equals minus 13. That's why it's really useful to check your answer, because I checked my answer and it was wrong. All right, minus 2x minus 6x plus 59 equals 13. Minus 13, almost forgot it again. Minus x equals minus 8x, sorry. Take away the 59, we get 72, which is a multiple of 8, and we get a much better answer here. X is equal to minus 9. Sorry, 9. They're both negatives. Too early in the morning to do maths. Now we have our answer. We can substitute it back in. Let's pick equation 1, because it was already set up in terms of x. Sorry, y. So that equals minus 6 times 9 plus 59 minus 54 plus 59. Nice answer. X equals to 5. Sorry, y is equal to 5. Very simple check again. Minus 2 times 9 plus 5 equals minus 18 plus 5, which hopefully equals 13. Sorry, minus 13. And it does. So we have a correct answer. 9 and 5, yes. Yes. Yes, well done. Yep. Okay, let's get to the next one. Want to be able to look at a few contextual questions here as well before we finish. Okay, this is a harder substitution method because now we have one equation which is still in terms of y, but our other equation has 5y in it. But we still follow exactly the same steps. We want to substitute equation 1 into equation 2, but we'll have to multiply this by 5 now. Let me use this. So, draw. So I want to sub 1 into 2. So we have 3x plus 5y is equal to 44, which means 3x plus 5y is just this, 4x minus 28 equals to 44. Let's expand. 3x plus 20x minus 28 times 5, 140 equals to 44. Getting pretty big here. 23x equals, add 140 to that, we get 184. I have a large number there, I'm not sure what's going on with this question. Dividing 184 by 23 will give us x is equal to 8. 8 times 20 is 160, 8 times 3 is 24, so 184 divided by 23 will be x equals to 8. Looks like a lot of people have had to go to class. Josh and Mega, you're the only two here now, so if there's anything in particular you would like to go over, just let me know in the chat and we can do it right now. But we'll finish on this question otherwise. Sub in x equals to 8. Let's pick the first one. Y equals to 4 times 8 minus 28. 32 minus 28 equals to 4. So our solution is 8, 4. So if we were to graph this, we'd know our solution is here, 8, 4. Y equals 4x minus 28. It's going to look something like that. 3x plus 5y equals 44. That's 5y equals 44 minus 3x equals 44 on 5 minus 3 on 5x. It's getting a bit complicated. Going to look something like that. And they'll intersect at this point here. Yeah, 8, 4. Josh and Mega both have it. Awesome. Next one, clear. Again, please just let me know if you want me to go over something in slightly more detail. All right, substitution method again. Now this one even trickier. We don't have either of our equations in terms of x or y simply. Easiest thing to do first, oh, they want to solve for x first. Okay, So we have these two y terms, plus 3 and minus 5. We want to multiply both equations by something that will make them equal. So let's times this side by minus 5, and let's times this side by 3 and see what happens. If I times everything here by minus 5, I get minus 10x minus 15y equals minus 5 times 26 is minus 130. Getting quite large, these numbers. Timesing by 3, in the second one, we get 24x minus 15y equals 3 times 36, 90 plus 18, 108. So now we have two equations. And conveniently, well, I say conveniently, we did it on purpose. We have these two terms here that are the same, minus 15y each. So that means that we can now subtract one equation from the other. So I'm going to I'm going to subtract, let's take away 1 from 2. So equation 2, 24x minus 15y, and I'm going to take away minus 10x minus 15y, which means that this is 108 minus 130. Let's quickly collect like terms. 24x minus a minus is plus 10x minus 15y minus 15y. They cancel out. That was the point. So we now are left with, oh, this is not looking right. 34x equals minus 22. Is that correct? Wouldn't have thought it was, but let's just press on and see. That would give us a very horrible number. I think I've definitely done something wrong there. What did I do wrong? I'm going to just start it all again. Something went horribly wrong there. Times that by 5. Let's do it this way. 10x, and it just times everything by 5. Keep it as positive. 130 times this by 3. Now I'll just add these two together. So 34x equals 238. That's looking a bit better. 238 divided by 34. 7 times 34 is 7 times 30 is 210. 7 times 4 is 28. So x equals to 7. That's a bit better. I don't know what I did earlier. Now we have solved for x. We can substitute that in to equation 2. 8 times 7 minus 5y equals 36. 56 minus 5y equals 36. That's much nicer numbers here. Let's do a quick rearrange. Take away 36 from both sides. Add 5y to both sides. 20 equals 5y, so y must equal to 4. So our solution here is 7, 4. Let's double check that by subbing into equation 1, 2 times 7 plus 3 times 4, 14 plus 12 equals 26, as we would hope. Now, I'm still wondering what I did wrong here. Now, I'm going to clear it and just do this another way. When you guys get these in a test or something, you probably won't have the instructions here to solve for x first and then solve for y. If I could do it in any order, I would probably solve for x first, because 2 and 8 have a common factor. So if I did equation 2 minus 4 times equation 2 minus 4 times equation 1, I would have 8x minus 5y minus 4 times 2x plus 3y must equal 36 minus 4 times 26. Let's expand. 8x minus 5y minus 8x, there we go, plus 12y equals 4 times 26, 80, 90, 80, 104. 36 minus 104 is minus 66, I think. Minus, oh, I can't. 36 minus 104, I can't count today. Minus 68. Now, collect like terms. These go. That was the whole point. Minus 5y plus 12y is 7y. That's not right. What have I done? I really cannot. No, 26. No. Oh, 100, yeah. 36 minus 104. What am I doing? For some reason, I just cannot think clearly today. X minus 5y minus 4, 2x plus 3y minus 8x. Ah, 36 minus, yeah. I just cannot count. Okay, Josh, it's just you here. If there's anything you want me to go over right now, please let me know, and I can teach you. You have a one-on-one lesson for yourself. Yeah, let me just double check it. 2x plus 3y is 26. 1.5y minus 13 equals x. That's a nice way of doing it. So, I was trying to use the elimination method, not the substitution method this whole time. Got to pay attention. Yeah, your answer is, let me just double check. Y is 20, x is 17. 8 times 17 minus 5 times 20 equals 80, 56, 136 minus 100, perfect. Y equals 36. Yep, that's correct. Let's just quickly go through the last couple before the lesson ends. This is a contextual one here. So a lot of information to take in first. So in this case, there are two accounts earning different levels of interest, and she wants to earn 204 total interest from the two accounts. This is quite a tricky one. So we know she has 3,000 to invest in total, so it's going to equal to 3,000. X is the amount she's investing in A, and A has a rate of 0.06. So we have 0.06x plus 0.08y equals 3,000. We don't know what X and Y is. They're the amounts that she's investing, but if we know she invests X dollars at 0.06 and Y dollars at 0.08 or 8%, that will equal 3,000. No, duh. Let's start again. X and Y is the amount she wants to earn. So yeah, with me 1 sec, Josh. I'm just loading up something. Okay. I think I was solving the second question first there, not the first one. So X, I misled you there, Josh, my mistake. X and Y is just the amount she wants to invest in each one. So what that means is that this equation here is just X plus Y equals 3,000. She's going to invest X dollars and Y dollars, and she wants to invest 3,000 in total. So we have this one equation, X plus Y equals 3,000. My mistake there. And then for part B, that's when we can use the percentages. So part B, we have 0.6x plus 0.06x plus 0.08y equals $204. Now, we want to get these to become whole numbers. So let's just times everything by 100. 6x plus 8y equals 20,400. And now we can substitute. We'll probably rearrange this one first to get x or y in terms of the other one. 3,000 minus y. Now we can sub in 6, 3,000 minus y. Or you could have used these tiny little values. Plus 8y running out of room. 1,800 minus 6y plus 8y equals 2,400. Big. That gives us 2y equals to 20,400 minus 18,000 is 2,400. Y equals 1,200. And they invested $3,000 in total. So we get y equals to 1,200. X is equal to 1,800. Okay, so if you started, just kept it as 0.06x plus 0.08y equals 204, you could still substitute in your rearranged values and solve to get the same answer. Clear, close. Let me just load another one up for you, Josh, and we'll go over it again. Can you see my screen now with the Mathspace question loaded? Okay, cool. Oh, this is not the question I wanted to load. This is what we're doing, isn't it? I'll quickly go over that other one as well. Okay, so we have just our first one, nice and simple, x plus y equals 5,000. That's the amount they want to invest. Total interest they want to earn is $394. So that will equal, we have a rate of 7% for x. And we have a rate of 0.9 or 9% for y. We have our two equations now. So what let's just do it this way. Let's not rearrange the first one, 5,000 minus y. Now we can substitute that in. So we have this equation equals 394. We know what x is equal to. So this is not multiplying it by 100. And I just don't like working with decimals, so let's just pick them up. That's 100, that's 100. Let's stick some zeros on there. That's now 100 times bigger. Are you fine with that step? So everything here has just been times by 100. That's now 100 bigger, that's 100 bigger. this is 100 bigger. So we've maintained equality. We can now just continue on. Oh, should be an equals. Collect the like terms, take away 35,000. And that means, what's that, 4,400. Y equals 2,200. Now solve for x. We know that 2,200 plus x was equal to 5,000. X is equal to 2,800. Cool. All right, let's do this one. These are the kind of things you probably remember doing in primary school, where if someone's like, I'm thinking of two numbers. So the sum of the first number and the second number is 13. And the difference between 5 times the first number and 7 times the second number is minus 19. Sum equation, that's nice and simple. X plus y is equal to 13. Oops, got to do this one. The difference between 5 times the first number and 7 times the second number is minus 19. So we have these two equations now. Let's rearrange for x this time, for y. Y is 13 minus x. I can substitute into this equation. That equals minus 19. 7 times 13, 70, 91. Plus 7x, we've got the two minuses there, so it becomes a positive. 12x equals minus 19. Let's add the 91 at the same time. It gives us 72. X equal to 6. Let's go back to this one. We knew that x plus y was equal to 13. We know x is equal to 6. So y is equal to 7. Cool. That's it. Do you want me to go over another elimination one or another substitution one at all? Let's pick a harder elimination one just to go over if you'd like. Okay, so first things you want to do for elimination method is generally, compare the coefficients of the x terms or the y terms. You can see here we have 7x and 28x. They have a common factor of 7. So if I times equation 1 by 4, this will become 28x. So 4 times equation 1, it's going to be one of these options. Oh no, it's going to be that one. Or this one. If I have 4 times that, I've got 28x on both, so I want to take away equation 2. Okay. So if I times equation 1 by 4, I'll have 28x plus 44y, and then I'm going to take away equation 2, 28x plus 7y equals, I've times minus 42 by 4, and I'm taking away minus 94. Did that step make sense? It's not the default step here. Let's see what Mathspace is suggesting we do. I have a feeling they've just, they haven't gone as far as I did. Let's go back to this step though. So that's going to be minus 28x minus 7y, and minus 42 times 4 is 90. And minus 88 plus 94 is 6. No, it's not. Wow, I was way off. I really can't do maths today. Minus 74. No, what am I doing? Oh. Yes, there we go. That makes it easy. So 28x minus 28x, they cancel. They can go. 44 minus 7y. 44y minus 7y is 37y. 37 goes into 74 twice, so y is equal to minus 2. Now we can just do a very simple substitution. 7x plus 11 times minus 2 is equal to minus 42. Add 22 to both sides. And we get a yucky number. Okay. Let's use elimination method really quickly on this demo, and then we'll call it a day. So it's very similar to the other one, but we're going to use elimination method. So we have x plus y is equal to 14. This is the same question, is it? No. 6 times the second number minus 6. So we're going to do elimination method here, which is possibly what I did last time. So let's do equation 1 minus 5 times equation 2. Oh, minus 5 times 14. Um, 50, 70 minus 29 minus 99. So we can get rid of the 5x's because we've got 5x and we're taking away 5x. Minus 6y minus 5y gives me minus 11y. And now I can just divide both sides by minus 11 and we get y is equal to 9. Oh, they wanted me to solve for x. No wonder this is not working. All right, let's do it the other way. 5x minus 6y minus 6 times x plus y equals minus 29. Back to this line again. Getting messed up here. I just need to plug my charger in. Solve for x, okay. Let's do it again. 5x, we know this. Add that this time, equals minus 29 plus 5 times 14. That's what I did wrong. No. Ah, 6. So minus 6y plus 6y, they go. 5x plus 6x. Now we're talking. 11x equals minus 29 plus 84. X equals 5. There we go. Now solve for y. Luckily, we already solved for y. Y equals 9. Okay, Josh, I've got to go now. Feel free to email me if you have any other questions, and I'm happy to help you. Have a good day, mate.